let's solve question number 19, guys. So what we have over here, we have this big organic compound over here, and this compound is treated with chromic anhydride to give you P. What is chromic anhydride? Chromic anhydride will oxidize the OH groups. And which OH groups will be oxidized? Let's see. The OH groups which are primary and secondary. The phenolic OH will not be oxidized and the tertiary OH will not be oxidized. So your this OH present over here, which is primary, will get converted to what? This will get converted to a double bond O. This will get converted to a double bond OH. Okay. This over here will also get converted to what? Will get converted to a double bond O. So which OH group is left which is not getting converted? You are left with two OH groups which are not getting converted, and those two are this phenolic OH group and this OH group which is tertiary. So these two groups are not getting converted to double bond O. So when you're adding ferric ammonium nitrate over here, what will happen? Your OH, that is D, and OH, that is B, will react with ferric ammonium nitrate. Hence your answer is what? Hence your answer is option 4, guys. Okay, it was a very simple question, just that you have to identify which OH will undergo oxidation and the OH which will not undergo oxidation, guys. Okay, and ferric ammonium nitrate is a reaction of OH group, guys. Okay, let us look at the next question. Okay, so a complex A has composition of H12O6Cl3Cr. If the complex on treatment with Conc H2SO4 loses 13.5% of its original mass, the correct molecular formula of A is: atomic mass of chromium is 52 and chlorine is 35 AMU. So these are our options. These are our options, guys. Now what we have to do is we'll have to first calculate the molar mass of the complex. And as we calculate the molar mass of the complex, the molar mass of the complex is, molar mass of the complex will be 266.5. Okay, so as the molar mass is 266.5, when you are losing 13.5% of it, so 13.5% of 266.5, that is how much? Let us calculate that. So 266.5, 13.5 multiplied by 13.5 divided by 100. So that will be approximately how much? That will be approximately 36 grams. So basically you are losing how many moles of water? You are losing 2 moles of water. You are losing how much? You are losing 2 moles of H2O. So if you are losing 2 moles of H2O, this 2 moles of H2O has to be outside the coordination sphere, right? So in which option we have H2O outside the coordination sphere? Okay, in the first option all the molecules of H2O are inside the coordination sphere. Second option, 2 molecules of H2O are outside, 4 molecules are inside. Third option, 3 molecules of H2O are outside and 3 molecules of H2O are inside. Fourth option, 1 molecule is outside and 5 molecules are inside. How many molecules are we losing, guys? How many moles are we losing? We are losing 2 moles of H2O. So the answer is option 2. It was a mixed question, guys. It was a mixed question that is from coordination as well as some concepts of physical chemistry. So it was an easy question. I hope you have understood this without any doubts. Okay. Yes. Let's proceed ahead. Okay. So here we have a question from Biomolecules. The number of C double bond O groups present in tripeptide ASP, GLU and LYS. Now what is ASP? ASP is aspartic acid. What is GLU? GLU is glutamic acid. What is LYS? LYS is lysine. Let us look at the structure of all the three amino acids. So these are the structure of the three amino acids. Okay, so first one that we have taken over here is aspartic acid. So this one is ASP, that is aspartic acid. In short, we'll write it as ASP. The second one is GLU and the third one is LYS. So if you know the structures of these amino acids, it is a very easy question, guys. How many C double bond O groups do I see? Here I have one C double bond O group. Here I have two. Okay. So in the first compound, there are two carbonyl groups. In the second compound, there are again two carbonyl groups, right? In the third compound, there is only one carbonyl group. So one, right? So the total is how much? The total is 5. So the answer to this question is what? The answer to this question is 5. Okay, I hope you have understood this. Just remember the structures and you will be able to identify the number of C double bond O groups present. Okay, let us look at question number 22, guys.